What's going on, guys? My name is Richard and welcome back to another Python for Finance tutorial. And today I've got a very cool program to share with you guys that can be used to determine whether or not the stock market is either deeply oversold or extended. And basically what we'll be doing is creating this histogram on the left and also this plot on the right that basically represents how far extended we are from a particular moving average. And the histogram on the left basically plots the histogram of the historical percent change extensions from that SMA, as well as the mean, standard deviations, the current extension from that 50-day SMA in red, and yesterday's in blue. And then over on the right, we have a zoomed in view of that percent extension plotted over the past couple days, and the user will be able to input this limit right here, which could be used as a warning signal. So I think this could be very useful in determining whether we've gotten ahead of ourselves, gotten very extended, or perhaps on the downside down here, we were well below the normal range, down 20% from the 50-day SMA. So if you see this in the future, it might be helpful to start looking for stock entries at this time and kind of get a head start so you're prepared for that fall through day. And to explain a little bit more about what this program is about, I do want to briefly show this plot in TC2000 that gives that percent change over the past couple years. You can see that when we have these historical lows, like in 2016, in 2018, you get deeply oversold from that 50-day SMA. And when you've got tops like this, you're pretty close to 10%. And currently, we're very close to that 10% margin as well. So I think this plot can be very useful, and it's very cool that we're able to build it in Python and really customize it however we want. So let's go ahead and build this program. So first things first, we're going to create that first plot. That's going to be the histogram, and we have to define some subplots here. So fig x1, and we're going to call that a PLT object, which if you look up above, we defined matplotlib.pyplot as PLT. So there we go. And next, we're going to get that information from Yahoo Finance. So df equals pdr dot get data Yahoo, and then we're going to pass it the stock, the start date, and now. So that should be good. And next up, we're going to actually calculate the moving average that the user wants to define the extensions from. So we're going to ask them for that moving average. So SMA equals int, and then in that input, and we're going to ask them to enter a SMA. And we're converting this string value to an integer, basically so we can use it within our program as an integer. And then we're also going to ask them for that limit, that caution sign. So if you go back to this plot right here, this line right here, we're going to ask them what value they want as that caution sign. So we're going to call that a limit. We're going to set that equal to int, once again, input, enter, warning, limit. And let's give a space to make it look nice. And there we go. And now what's left is to actually calculate that moving average and that percent change from that moving average for every single day. So here we go, and I'm just going to copy the code from the previous programs right here because it is quite long to type out and I don't want to make a mistake. So this calculates the moving average, and it takes in the adjusted close column right here. That's df.iloc colon comma 4, and then it uses a pandas basically function to calculate that moving average for each value. So we've got the moving average, and then what's next is to actually calculate that percent change, which we're going to call PC, for each of those days as well. So for each day, we're going to use the adjusted close divided by that SMA value, and then subtract 1, and then multiply by 100 to find that value. So we've actually got most of what we need to calculate, but we also need the mean and standard deviation. So we're going to say mean equals df, and we're going to get the PC dot mean. So it's nice that, that shouldn't be in there. It should be outside. It's very nice that they've got these built-in functions that we can just use. So next we need the standard deviation, stdev equals df pc dot stdev. Oh, it's just std. It's not stdev. And we're also going to want the current extension and yesterday's extension. So we're going to say current equals df pc and -1. So this gets the most recent value of that extension. And then for yesterday, it's very similar. Yesterday equals, or actually let's call this yday equals df pc and then -2. And now let's print this out and we'll run it quickly just to make sure we haven't made any errors. And then we'll get on with actually plotting everything. So print mean colon plus str mean, and then we're also going to print that standard deviation. There we go. And let's save that and let's run it. And actually I think at the end of this loop I do have to say this just so it's not infinite loop. And there's our first error. I forgot this should be subplots, not just subplot. Let's save that and run it again. There's always going to be errors. You just got to deal with it. If you do run into problems, either leave a comment down below in this video. I'll try to help you out, or just try to find it on Stack Overflow. But usually it's just a quick typo like that. So we're going to use the 50-day SMA. Let's do 10. And there you go. It outputs the mean and standard deviation. So you can see that usually actually the extension is just a little bit over or a little bit under 1% from the SMA. So where we're at right now, around 10%, that's pretty far. So that's why I think this can be useful because when we are this extended, even though this has been a very powerful rally, it is a reason to be a little bit more cautious. So it's just going to ask us for another stock, but we'll just say quit and let's get on with plotting these results. So next up, we'll actually start plotting the histogram. And if you remember from the histogram, it doesn't just plot every single value. It will actually plot within bins. So for instance, 10.4% and 10.5% will show up in the same bin. So we're going to say bins equals np.arrange, and we're going to pass it -100, 100, and 1. And this third value is what's significant here. We're basically going to use bin sizes of 1%. And if you want to change this, go ahead. It's completely personal preference. So now that we've got that, we actually can start with the histogram. So first we'll define some limits for the histogram just so it looks nice. So xlim, and we're going to say in here df pc dot min, and then we're going to say -5, so we want a little bit further than the edge of the minimum, and then we also want this, so the maximum is a little bit further from the maximum as well, and that is good. And now we need plt.hist. And we're going to pass the data, which is that df column called PC, and we're going to pass it bins equals bins, which is the variable that we defined right here, and we also want alpha equals 0.5. And this alpha value is basically the opacity of the plot, and once again, you can change this if you want. All right, so now that we've got this far, let's go ahead and run it real quick, and we need to show the histogram. So we'll do plt.show, and I've got two of these right here, so let's delete this top one because we want to ask for the next ticker symbol after we actually show the histogram. So getting rid of that, let's save it and run the program. So let's quit out of this one and run it once more. There you go. It prompts us for the cues, the 50-day SMA, and we'll do 10 here. And there you go. There's the histogram that we want. And now we just have to add a little bit of detail. So let's X out of that and do quit. And let's add those labels. So first things first, under here, we're going to do a couple different titles. And I'm just going to copy this because it will be quite a bit of typing. So let's copy that and do it like this. So right here is the main title, and we're going to do stock plus % change from that SMA since whatever year we choose. And then we also want the X label, which is the percent from that SMA once again. And then on the Y-axis, we're going to have the overall count. So let's save that and run it and see that added detail. So here we go. We're going to be asked for the Qs, the 50-day SMA, and 10. And there we go. Now we've got these nice titles here to add that basically extra information. So if you remember from the example that I showed you, we're also going to plot the mean and the standard deviations. So to do that, we're basically going to use this format right here, which I'm copy and pasting right here, which is basically the plt.axv line, so vertical line, and we're going to set the x value at either the mean or standard deviation. The y min is 0 for the bottom of the screen, the y max is the top, the color is K for black, and the line style is dotted lines. So this is the one for the mean, and we're going to have this in black, but we also want to have it at mean plus stdev, and we're going to make that gray. And we're going to do this for each standard deviation, so 1 standard deviation, 2 standard deviations, and 3, and also the negatives. So let's copy and paste this, and we'll do the other ones as well. So we're going to do plus 2 times, and this one is going to be plus 3 times. And we need this plt.show to be after these vertical lines. And now that we're here, let's go ahead and do the negatives as well. So let's do this. Mean minus standard deviation, minus 2, and minus 3. And if you don't know much about a kind of a normal curve and standard deviations, I want to show this graphic right here. This is kind of the methodology behind this entire program. If this distribution approximates a normal curve, then most of the time it should be within 1 standard deviation of the mean. And that encases 68% of all data, or should, and 2 standard deviations should be 95% from that mean. So that means if we're 15-20% above that 50-day moving average, we're very likely to fall back and correct a bit, so we're back within this curve. And if we're way outside 3 standard deviations, that definitely means that we're due for a reversion to the mean. So that's a quick statistics lesson right there. And let's get on with the program. And there we go. Now we've got these standard deviation lines. So now that we've got this right here, we also need to add the current and yesterday's extension from that 50-day SMA to this graph, and then also make the other graph. So to add the other vertical lines, we're going to use the same thing right here, and we're going to make the first one x value be current. The second one is going to be y day, and we're going to set this one equal to red, and we can just do R here, and then this one is going to be blue, and we can also just delete these line styles because we want a solid line. So there we go. And now we're ready to build the second graph here. And before we do that, I do want to just add a few more labels down there on the x-axis. So we'll do ax1.axis.set_major_locator, and we'll do mticker.max_n_locator, and we'll give it 14 labels down there. So let's save that. And now let's move on. So we want to create another graph, so we have to define more subplots. So we'll call them fig2 and ax2, and we'll set them equal to plt.subplots. And there we go. So for this one, it's a lot easier. We're not using the histogram, so we can just do df pc.plot, and we're going to say label equals close, and let's set the color equal to black. So color equals K. So color equals K. And we're also going to add a title, and I'm just going to copy this right here. And it's not a histogram, so we're just going to say over the past 150 days. So there we go. And we also need to restrict it to 150 days. So below this line right here, we're going to say df equals df, and we're going to say minus 150 and colon. So this basically cuts off the last 150 and uses that to define this new df pandas data frame. And the x label is now actually just date, and the y-axis will be that percent change. So let's copy this right here, percent from that SMA. So there we go. I think that's pretty much all we need to do. And let's also add a little bit more information down here. So let's do AX1, but let's switch this to AX2, and let's do 8. And now we also need to plot that horizontal line. So instead of V line, we'll do H line. So here we go, plt.ax H line, and instead of X, this is Y, and this is limit. If you remember, we asked the user to define that here, and Xmin and Ymin. And I think I misspelled something down here. Yes, this should just be A. Let's save again. And I also need to spell that right. And there we go. And there we have the plots showing up. So here we've got the histogram on the left, and also the plotting of that percent change on a daily chart. So we don't have this red line here. Let's see if we just made a quick mistake on that. So it looks like maybe we're actually right on top of it. So that code actually looks right. But let me know in the comments if this isn't right, I'm missing something. But overall, I think that's pretty much all we wanted to do with this program. I hope you guys find this interesting. I think it's always cool to be able to use Python and statistics to try to find an edge in the stock market. So I hope you guys found this useful. And if you did, please go ahead and leave a like down below. And if you're new to the channel, go ahead and subscribe as well. But thanks so much for watching, and I'll see you guys in future videos.